Our planet is teetering on the edge of a cosmic catastrophe. Renowned astrophysicist Neil deGrasse Tyson, a voice trusted by millions, has sounded the alarm. In the vast expanse of our solar system, an asteroid named Apophis lurks, and its potential collision with Earth could be catastrophic. On Friday, April 13, 2029, this colossal asteroid will pass within a mere 19,000 miles of our planet's surface, closer than some satellites. But the real question is, what happens next? Could Apophis collide with Earth in 2068, unleashing devastation beyond imagination? And how prepared are we to deal with this cataclysmic scenario? Let's find out. Apophis, a terrifying discovery. 2004 was a time when our understanding of near-Earth objects was still evolving, and the tools at our disposal were just beginning to scratch the surface of the universe's mysteries. It was during this period that astronomers, using the Kitt Peak National Observatory in Arizona, stumbled upon a discovery that would send ripples through the scientific community. The asteroid, initially designated as 2004 MN4, was later christened Apophis, after the ancient Egyptian god of chaos and destruction. A fitting name, some might say, for an object that would soon become the subject of intense scrutiny and debate. But what was it about Apophis that made it stand out from the myriad of other space rocks hurtling through space? Why did this particular asteroid become the talk of the town, drawing the gaze of astronomers and space enthusiasts alike? The initial observations of Apophis revealed it to be a sizable object, with estimates suggesting a diameter of approximately 1,200 feet. While this might not sound particularly large in the grand scheme of things, in the realm of near-Earth asteroids, it's substantial. To put it in perspective, that's roughly the size of 4 football fields laid end to end. But size alone wasn't the only factor that piqued the interest of the scientific community. Have you ever had a moment where a discovery was so unexpected that it took a while to fully grasp its implications? That's precisely the sensation that swept through the astronomical community upon Apophis's discovery. The asteroid's unique orbit and characteristics made it a subject of fascination. Its spectral type, classified as an SQ-type asteroid, indicated a stony composition with a hint of metal, giving it a slightly reddish hue. This composition, combined with its size, made Apophis an intriguing specimen for researchers keen on understanding the makeup of our solar system's early building blocks. But beyond its physical attributes, it was the data surrounding Apophis's trajectory that truly set the stage for the discussions that would follow. We'll tell you more about that later. For now, let's take a step back. How do astronomers even detect such objects in the first place? The process is a testament to human ingenuity and the relentless pursuit of knowledge. Using advanced telescopes equipped with state-of-the-art sensors, astronomers scan the night sky, looking for moving objects against the backdrop of distant stars. Once an object is detected, its position is tracked over time, allowing scientists to calculate its orbit and predict its future path. But what did Neil deGrasse Tyson, one of the most prominent astrophysicists and science communicators of our time, have to say about Apophis? From the outset, he recognized the potential implications of an asteroid of Apophis's size and trajectory. While many in the scientific community were engrossed in the technical details of the asteroid, Tyson used his platform to raise awareness about the broader implications of such celestial bodies. In fact, one of his most quoted remarks about asteroids is, "The universe is a deadly place. At every opportunity, it's trying to kill us. And so is Earth. But human beings are really good at not dying." And as we delve deeper into the mysteries of Apophis, we'll find that the universe indeed has its own set of surprises. So keep watching. 2029, a ticking time bomb in a startling revelation, the solar system seems to have a peculiar sense of timing. On Friday, April 13, 2029, a significant event is set to occur. Apophis, a massive asteroid stretching about 1,100 feet across, will make a close approach to Earth, passing within a mere 19,000 miles of our planet's surface. To put that into perspective, that's closer than some of our satellites orbiting Earth. But before panic sets in, it's essential to note that scientists are confident that Apophis will not collide with Earth during this encounter. Instead, this event presents a unique opportunity for researchers to gain invaluable insights into asteroids that come close to Earth. Yet, as we'll explore later, there's an even terrifying twist to this cosmic tale, one that involves the return of Apophis in 2068. Did you know that such a close approach by an object of this size occurs only once every 1,000 years? This makes the 2029 event a truly unique spectacle. Richard Binzel, a planetary scientist at MIT, emphasized the significance of this event during the International Academy of Aeronautics Planetary Defense Conference. He highlighted that the asteroid's size and proximity would make it so bright that approximately 2 billion people could witness its passage with the naked eye. Imagine looking up at the sky and seeing an asteroid, a relic from the early solar system, passing by so close. One of the most intriguing aspects scientists are keen to study is the Yarkovsky effect. This phenomenon arises due to the temperature difference between the day and night sides of an asteroid. The heat emitted from an asteroid's surface can exert a tiny force, nudging the asteroid in a particular direction. While this effect is minuscule, over time, it can significantly alter an asteroid's orbit. 4. Apophis, understanding the Yarkovsky effect is crucial. Although its 2029 trajectory is well defined, the uncertainties associated with this effect make it challenging to predict the asteroid's path in the distant future. Now, with a decade to prepare for Apophis's close approach, scientists are gearing up to gather as much data as possible. This information will not only enhance our understanding of Apophis but will also provide insights into other potentially hazardous asteroids. After all, Apophis is believed to be similar to about 80% of the potentially dangerous asteroids that have been identified so far. But here's a thought to ponder: what if we could study Apophis up close? Scientists are already exploring the idea of sending spacecraft to observe the asteroid before, during, or after its 2029 flyby. Drawing from recent successes in space exploration, such as NASA's Mars InSight mission and the Hayabusa 2 asteroid mission, researchers are considering various mission concepts. Some of these include placing a seismometer on Apophis to study its internal structure or even creating an artificial crater to observe its subsurface. However, with great knowledge comes great responsibility. Given the asteroid's close approach, there's a heightened responsibility to ensure that any human intervention doesn't inadvertently alter its safe trajectory. 2068, the year of reckoning. But what about the future? What if the 2029 flyby isn't the only close encounter Earth has with Apophis? The year 2068 looms large in the minds of many astronomers and space enthusiasts. Why? Because that's the year when Apophis might, just might, collide with our planet. This is where the concept of the keyhole comes into play. Imagine throwing a stone into a pond. If you throw it at a particular angle and speed, it might skip once, twice, or several times before sinking. Similarly, a gravitational keyhole is a small region in space where if a passing celestial body, like an asteroid, goes through, the Earth's gravity can alter its trajectory. In the case of Apophis, if it passes through a specific keyhole during its 2029 flyby, it could be set on a collision course for 2068. Now, let's pause for a moment and consider the implications of such an impact. What would happen if an asteroid the size of Apophis struck Earth? The moment it makes contact, the immediate vicinity of the impact would experience cataclysmic devastation. The asteroid, traveling at speeds of several miles per second, would release energy equivalent to billions of atomic bombs. This would result in the formation of a massive crater, potentially several miles in diameter. The heat generated from the impact would be so intense that it would instantly vaporize the asteroid and a significant portion of the Earth's crust at the impact site. This would lead to the ejection of molten rock and debris into the atmosphere, creating a fireball that would incinerate everything in its path. If Apophis were to strike an ocean or sea, the consequences would be even more dire. The impact would generate colossal tsunamis, with waves reaching heights of several hundred miles. These waves would travel across entire ocean basins, wreaking havoc on coastal cities and settlements. The sheer force of the impact would also trigger seismic activity, potentially causing earthquakes thousands of miles away from the impact site. Regions unaccustomed to seismic activity might find themselves grappling with unexpected and powerful tremors. The aftermath of the impact would have long-term global consequences. The vast amount of debris ejected into the atmosphere would block sunlight, leading to a phenomenon known as an impact winter. This could last for months or even years, causing temperatures to plummet worldwide. The lack of sunlight would severely disrupt photosynthesis, leading to a collapse of the food chain. Crops would fail, and ecosystems would be thrown into disarray. This would result in widespread famine and a significant reduction in biodiversity. The socio-economic implications of such an event are hard to fathom. Infrastructure would be destroyed, economies would collapse, and the very fabric of societies would be tested. The immediate focus would shift to survival, with nations and communities grappling with the aftermath of the impact. Governments and organizations would need to come together to provide aid, rebuild, and ensure the survival of humanity. It's a bleak scenario, but it's one that scientists are determined to prevent. The threat is real. The threat of an asteroid impact is not a distant, theoretical concern but a real and present danger that demands our attention. Apophis serves as a stark reminder of the potential devastation that could befall our planet if we remain complacent. It's a wake-up call for humanity, urging us to take proactive measures to safeguard our future. NASA, along with other space agencies and organizations, is working tirelessly to develop strategies to mitigate the threat of asteroid impacts. One of the primary methods being explored is deflection. By altering an asteroid's trajectory even slightly, it can be nudged off a collision course with Earth. This can be achieved through various means, such as using the gravitational pull of a spacecraft, impacting the asteroid with a high-speed projectile, or even employing the force of a nuclear explosion in space. However, deflecting an asteroid like Apophis is no small feat. It requires precise calculations, advanced technology, and international cooperation. The 2029 flyby of Apophis presents a unique opportunity for scientists to test and refine these techniques. By studying the asteroid up close, they can gather critical data that will inform future deflection missions. One such mission that has garnered significant attention is NASA's Double Asteroid Redirection Test, DART. Scheduled to launch soon, DART aims to demonstrate the kinetic impactor technique by crashing a spacecraft into the smaller of the two Didymos asteroids. The goal is to alter its orbit and measure the effectiveness of the impact. The lessons learned from DART will be invaluable in developing strategies to deflect larger, potentially hazardous asteroids like Apophis. Another crucial aspect of planetary defense is early detection. The sooner we can identify a potential threat, the more time we have to develop and implement a response. This is where initiatives like NASA's Near-Earth Object Observations (NEOO) program come into play. By continuously scanning the skies for near-Earth objects, scientists can track their trajectories and assess the risk of impact. Collaboration is also key. The threat of an asteroid impact transcends national boundaries, and it requires a global response. The International Asteroid Warning Network (IAWN) and the Space Mission Planning Advisory Group (SMPAG) are two examples of international efforts to coordinate planetary defense activities. By sharing data, resources, and expertise, nations can work together to protect our planet from this cosmic threat. While the prospect of an asteroid impact is daunting, it's important to remember that humanity has the capability to prevent such a catastrophe. The advancements in space technology and our growing understanding of the cosmos equip us with the tools needed to safeguard our future. But it requires vigilance, investment, and a commitment to planetary defense. In conclusion, Apophis serves as a stark reminder of the ever-present threat of asteroid impacts. Its close approach in 2029 will provide a unique opportunity for scientists to study the asteroid and refine deflection techniques. The potential impact in 2068 underscores the urgency of developing effective planetary defense strategies. By working together and leveraging our collective knowledge and resources, we can ensure that Apophis, and other asteroids like it, pose no threat to our planet. The cosmos may be vast and unpredictable, but humanity has the power to protect itself from its dangers. So, while we keep an eye on the skies, we must also keep our feet firmly on the ground, ready to face any challenge that comes our way. The potential threat of an asteroid impact on Earth has captivated the scientific community and the public alike, with Apophis standing out as a particularly compelling case. Named after the Egyptian god of chaos, Apophis was discovered in 2004 and quickly became the focus of intense study due to its alarming trajectory. This asteroid, about 1,100 feet in diameter, is set to pass perilously close to Earth on Friday, April 13, 2029. At a distance of just 19,000 miles, it will come closer to us than some of our satellites, providing a unique and somewhat unnerving spectacle. This event will be a rare opportunity for astronomers to observe an asteroid of this size from such a short distance. The 2029 flyby will be so close that the asteroid will be visible to the naked eye, a reminder of the dynamic and sometimes hazardous nature of our cosmic neighborhood. The gravity of the situation is underscored by the possibility that Apophis could pass through a gravitational keyhole, a small region in space where Earth's gravity could significantly alter its orbit, setting it on a potential collision course for a future date. This raises the stakes considerably, transforming a close pass into a potential disaster scenario. Looking ahead, the year 2068 has been identified as a potential date for a collision, should Apophis pass through this keyhole in 2029. The implications of such an impact are staggering.